So our next session, I think there was a hint to it this morning, AI Package Wizard. Two super intelligent, smartest people at Cisco, Viktor, a distinguished engineer, and Sahithi, both from the automation team. So you guys are going to come up here and talk about this cool AI thing, which sounds really good for me, because I'm good with template-based services. You know, any Python code, I call Viktor. So it's great. I think you invented this for me, I think. Okay, perfect.
So a lot we've been doing today has been fairly complicated. And today we're talking about AI and making it a little bit simpler. And that's not because the world has gotten simpler, it's because the AI is not good enough yet. So we have this standard problem, right? We spend a little bit of time on as network automators. We have a service configuration, usually a CLI template format of some kind, and we want to turn it into a service. And as we build services, there are a number of different components to a service, right? So we have this sort of anatomical view where we start with building a service model, right? We want a Yang model to represent the stuff we have. We need to build a template. In our case, write the XML template NSO, and we need to write a little bit of Python code. So what we've been going to be talking about today is how can we leverage an AI to do this work. And what I'm going to show you today is some real working code, and Sahithi is going to get to that in a moment. But what's really exciting to me is the idea that we can make this better over time. So we call this the NSO Package Wizard. It is, you know, Microsoft's Clippy for NSO. The idea that you can start with a simple prompt and the wizard will guide you through the process. Now, I'm sure many of you have played around with AI coding tools, done a little vibe coding, and what you see there is that they have a very unstructured approach. But what we know with NSO, and Sahithi can talk more about this in a moment, is that there is a structure. If you work with a customer or a stakeholder organization, when you build a package, you have a very well-defined process where you sort of walk through the service development problem step by step. We want to have the wizard do the same thing and ask sort of the same kind of questions. So the example here, right, is a preview of demo I see in a moment. And what we do is let the user provide the configuration and the behavior and answer questions when prompted by the AI. And the long-term goal here is to be able to build this sort of task-driven assistance, where what you're asking for is driven into tasks, and the tasks are answered by the AI and the human together. And we're going to show you the first thing today. And there are going to be some questions towards the end, because our hope is that over time we can really, really expand this. As you saw on the slides, right, this is planned for the first half of the next calendar year. So there's a lot left to do. And that also means that we're really looking forward to your feedback and sort of understand what kind of things you want to do. Because what we're going to show you in just a moment is really, really interesting. It represents a class of work that we spend collectively a lot of time on. But let us talk more in the future about what the next steps are. So we'll go through the architecture and sort of what we're actually implementing here.
Sure. Thank you, Viktor. So before going into NSO Package Wizard, I want to speak about on what we have built this NSO Package Wizard on and why we have done that. So when we started out with this NSO AI coding agent, we understood that over time, the requirements are going to evolve. And we also understood that it is not a static execution of tasks which would lead to this NSO package artifacts generation. So this would be a dynamic thing based on the user input. we would have to rearrange these tasks and evolve accordingly. So with that in mind, we have come up with a generic and an extensible framework. We are calling this adaptive task management system, or a framework. And within that framework, the core of that framework is something called smart tasks. And we make sure that there is a goal for this framework, and we make sure that each of these smart tasks are executed until we reach the goal. Here, for NSO Package Wizard, it would be generation of these NSO package artifacts. So I'll dive a little bit into theory here on what this framework is about and what it consists, so that you get the fundamentals. So we have the central task management system that's like the supportive system for this smart task, what we are calling it as a smart task. The central task management system, it provides memory. That is, it provides the context to each of these tasks. It also makes sure it organizes the task and rearranges the task as necessary. It monitors the task. That is, in case, like, if this task is ready to execute, it monitors it and then executes the task as well. And coming to the smart task itself, there are three main components to this smart task. First is the preconditions. For that preconditions, it can be as simple as another task being executed before this task to be completed, or it could be some kind of logical expression, a rule-based expression, or it could be a LLM call. So once the preconditions are met, it goes into the second component, which is the execution method. Here, we provide a support for hybrid execution. What do I mean by that? This task can be either executed by a human, that is, a user can execute this task, or it could be an LLM call, or it could be a regular procedure call. And once that execution is done, depending on the result or the feedback of that execution, it goes into this task decomposition component. What that does is, depending on the result, it decomposes into several other tasks. For example, let's say the task itself has failed, it would decompose it into the same task, and it will be added into the system. But this task decomposition, it could be a LLM-based task decomposition or a rule-based task decomposition, because especially when you have a LLM call in the execution, you would not have the same results. So depending on the result, you would have a different kind of task decomposition happening here. And finally, we have a goal for this whole framework, and we make sure that everything, all these tasks, converge towards that goal. Eventually, we need to meet that goal. Until then, all the tasks need to be producing some kind of subtasks. All right, now coming back to the NSO Package Wizard. So we have built NSO Package Wizard on the framework which we have spoken about until now. So NSO Package Wizard, we thought the ideal place to build this would be our Visual Studio IDE, because it is seamless for the developer to actually build your package and then start developing on it if they have any kind of enhancements or changes they need to do. They can use the existing developer tools within the Visual Studio to, actually modify this. And one of the main things with NSO Package Wizard is, once you start this task engine, the NSO package initial plan is set. What do I mean by initial plan? As application developers on NSO, we already know that there are certain set of things which we do. Like, we have to create a Yang, we need to create a Python package. These are certain set of tasks or base plan which we create. But as the tasks are getting executed, depending on the user feedback or depending on the result, newer tasks are spawned off. For example, let's say the device configuration is not correct, or the user decides that this is not the configuration they want the package for. They should be able to give an input, and they should be able to spawn new tasks and get the user input again. And the wizard makes sure that all these tasks are being executed until eventual goal, which is our NSO package artifacts, they are generated. So this is the basic design of our package wizard. We have our Visual Studio as our user interface. We use TypeScript and JavaScript for our Visual Studio plugin. And backend, we have our task execution engine. Sorry for using the abbreviation here, but DAG means Directed Acyclic Graph. What it means that it is a graph which is sorted based on dependencies. So we use that graph to organize our tasks. And here, whenever there are no dependencies, these tasks go into execution. And here we define, or we split this task into two different types. The first is the user task, and next is the system task. The user tasks, they go to the user interface, gather the user input, and come back. And these are sequential in execution. We chose them to be sequential because we do not want to bombard user with a lot of, to give a lot of input. So this way they can focus on one task at a time. And then you have your system tasks, which can be executed in parallel. These can be LLM calls or your regular method calls. All right. So this is the NSO package internals. So at the initial moment of time when the server is just spinning up, you would have your NSO package generation task. This is where in case of this NSO package generation, I use rule-based because we have been FP developers and we know what set of steps we need to do to create a package. So we have this set of rule-based tasks, which the first task decomposes into. At further point in time, you can see that how the tasks have evolved. Like you see the gather user intent, that would be the first task which goes to the Visual Studio. And then you have identifying NAD, setting up your NSO, and so on, right? And as time goes forward, this need not be, the graph wouldn't be the same. It would evolve over time as the user interacts with the NSO package wizard. Then once the dependencies are being executed, you can see that these tasks are sent into two different types of tasks. The first one is package generation conversation with user. Here we use a priority queue so that we maintain context with the user. We want to gather all the user input within the context at same point of time so that they don't need to context switch often. So you can see how we start gathering our user intent and net ID, and depending on user feedback, this might change. Similarly, system tasks, you can see we have template generation where we leverage NSO methods to actually generate template from our device configuration. And then we have identify net ID, which we use LLM to do this. Okay, so this is the screenshot which I grabbed from my server. It just shows you like the first set of decomposed tasks. You can see these are the tasks which I have defined as first initial plan, how we can gather intent, creation of directories, and your package creation, identifying NAD, and all that stuff. And once these are done, you can, and the server starts running, this sends out a response. This sends out a response to your Visual Studio interface, which shows and I'm going to show that in a live demo. All right, let's now maybe go to the demo. Okay. All right, so this is how our user interface looks like. This is our plugin, which I've already loaded. And on the left-hand side, you can see like the empty directory on this is what I have configured where our artifacts would be generated. So I'm going to, like I have a prompt with the device configuration already set with me. And I'm going to paste it over here. All right, so you can see, I want to create a service package based on segment routing. I have given the segment routing configuration over here, and now I expect a proper running package where I can create service and actually provision this configuration. Now let me run this. All right, so keep observing on the left-hand side, you can see all the artifacts being generated real time. Right now, there are no packages. We are just setting up the workspace for the user to work on. And what we are doing here is we have some set of supported net IDs, which the user actually the LLM needs to understand. Okay, let me first. I want to add this as a demo. Okay, so LLM has identified that this particular configuration is Cisco ISXR configuration, and it identified that this is one of the nets which we support, and it has chosen this net. And if we are okay with that, we can just proceed with it. And as you see on the left-hand side, our artifacts are being actually generated as we go. All right, we have our template, we have our package, we have our net being set up in our packages. And now we are going back to the LLM. Here, what happens in the background is that we are actually getting the template from NSO by loading in our device configuration, and we are sending it out to LLM to actually identify what are the parameters it needs to, what are the variables which can be parameterized. And if we are okay with all these variables, we should be like, okay. Now, all right, so once we have established the template, this is how we usually develop our function packs as well. We establish our templates, and then we start creating our Yang. Now we understand, what kind of variables we would need the user to input so that we can, apply or provision this configuration, right? And you'll also observe that the time taken for getting back from our backend is quite long for something like a Yang generation compared to a net ID selection. That's because for different tasks, we are using different kinds of LLMs. For a task where we would need to select our net ID, we use GPT 4.1, which is much faster in responding. But for a Yang creation task, we use a reasoning agent, and we have found that reasoning agents like O1, O3 are much more reliable with Yang generation, and they have been pretty consistent. Now, let's look at the Yang which is generated. You can see that it has been properly generated. We have our namespace, our description, and the service point and everything. So this Yang has been generated with our template, with the variabilized template as our context and also device configuration. So if we are good with all of this, we can just say that we have no feedback, we are good with this. We should be able to modify this at any point of time. Now that we have our Yang and our template, we need our service code, which needs to stitch this template and Yang together. That is like populate your data from your Yang to the template. So even this is an LLM call. What we do over here is we actually taken the skeleton, which is provided by NSO itself, provide it as a context, and it also has the template and the Yang and the device configuration, whatever was provided until now, as the context, and we send it out to the LLM, and it comes up with this, which is pretty good. So once we have these variables added in or populated into the var, we apply the template here, and you can see that if we're okay with this, now we have all the artifacts which are required by the package to actually get the package running and everything. So we are good to go. But this is our artifact for sample data. So we do want to test out our service once we have created the service, right? So I'm just going to give this demo. And all right, we are done. We have our unit tests ready. We have our sample template ready, and we also have our package ready. Let's go and check out. And if you want to do any modifications, we should be able to actually do any modifications and actually use the existing, existing AI tools to start working on this package which has been generated, right? So I can just say, explain, highlighted code. So it should be able to explain whatever has been generated by our package wizard, and you should be able to modify, right? So you can see the Yang over here, and our test is actually populated. So you have our sample. So I'm going to run the Lux test. Right, just give me a moment. But I'm going to run from a test which I've already generated using the package wizard quite earlier, because I have run it and it is successful. So lux.run. It's just a simple test which actually creates your device, a dummy device, creates your service, and then makes sure the service is created. It goes through the logs and has that create option, and and confirms that it is deleted as well. And you have all the artifacts which are required for you to, have the package ready and running. So that's for the demo.
Maybe you could show what happens when you have a bad first prompt, where you don't have the conf. You have to show that there is not just a set of steps.
Oh, so you want me to show?
That's what happens if you start a new package and don't give a good prompt. Do you have?
Okay. I think I would need to restart.
That's fine.
Okay, I would need to restart the plugin here.
Yeah.
One sec. Okay.
I'm messing with your plans, I'm sorry. But what's interesting here is that while it works really well, you can also see that AI is fairly unimaginative, right? It makes sort of everything into a variable. There's some that we have this edit possibility. You can sort of guide it in the right direction. So, you can try and get some nicer models. And we talked about sort of further evolution. We want to talk about this in a moment. Having the opportunity to do more to refine the model and have more heuristics for how to refine the model would be an interesting choice. Obviously, in the end, it ends up being a sort of a human choice which variables really matter or not. But, we can have the AI help you write a nice model, sort of working one. Do you think it works for AI? It's going to make you force something you didn't plan?
No, I haven't planned for it. I haven't tested without a proper prompt. Do you want me to test it out?
Yeah, sure. Let's see what could go wrong.
Okay. So service package for route text. and I don't give any device
That's
configuration?
fine. I'm sure it will work out.
I'm sure it's going to fail.
Well, it's going to fail, right? Of course, because you don't have the information you need.
Right. Yeah, I think it's going to get stuck here because.
Yeah, the server's not ready, of course.
Right. Yeah.
Never mind. Cool.
All right. I'm going to. Maybe you can switch back to slide.
Cool. So I'll wrap this up.
Thank you.
So this is pretty cool, right? And we're going to be done in just a moment. So what have we shown, right? We've shown a wizard can build some simple packages, and we have run a few different test cases. It's fairly consistent in finding the right templates and rank Yang models. As I said, a little bit unimaginative, so it tends to write fairly naive packets, but it works. It's built on an extensible framework, and that's what we're sort of most proud of, the fact that we can keep adding refinements to this and new types of tasks and new ways of breaking tasks down. We are improving and extending this as we go. As we was talking about, the plan is to start having this ready first half of the next fiscal year. So let us know what kind of tasks you want to automate, what kind of features will be useful to you, and hopefully, way before next developer days, we come back to you with something that you can use. So let us move on to this. We have a break in a moment. Let's see if you have any questions. Is this not right? Yeah, slide one. Yeah, cool. So first we have a rating question. Please try and rank the features we have. Take a moment for that. And then once you're done with that, any questions you have, any sort of,
Creating NED packages, wow.
Well, I mean, probably would have to be sort of net confidential stuff, right? The kind that you usually create. The C-line net is a very, very much more heavy thing. But it's one of those things that in some ways isn't that hard, but it's an awful lot of kind of fiddly steps where we could definitely do something useful. Another thing is sort of to talk about documentation and test cases. I started to use some of the coding agents a lot more for internal work. And that's definitely one of those cases where AI shines. They do not get bored the same way that I do, which I find helpful.
After the last two presentations, we should have had reconcile services AI.
Yeah, so I think there's an AI case for that, but I think it's slightly different. And I've told someone out in the conference, right, that when you talk about foresight, and we love to talk about foresight, we're talking about something that's very much in the operations phase. But in this conference, a lot of the work we're talking about is in the design phase, right? So design and operate is fairly different. And this is, sort of separated by that. And this is more about how do you make your system ready for operation? How do you get test cases? How do you get packages, right? So.
Yeah. Awesome. So before we get to these questions, this is incredible. This is incredible. I think all the service programmers in the room, don't tell your bosses about this, because then you'll have, you'll be able to go fishing in the middle of the day while your AI bot is doing your work for you. So that's a joke. But when you did the example, and Viktor, you alluded to this, so it kind of parameterized all of the variables. But a good service code writer, who has domain knowledge, will say, these are the service variables I want to expose northbound. These are the ones that I want you to pull from a resource pool. These are the ones that I just randomly, put whatever you want in there. So if you actually said something like that, would it actually have the smarts now to, kind of make that efficiency, or would that be something we would be looking to add?
So right now, you have the step where you confirm the variable. So you can choose what is not exposed, but there's no way of using a resource manager or something like that.
Okay.
That would be a next step.
Right. Well, again, it's great. It builds the skeleton, the framework, and then that's 90% of the job, and then you can go in there and you can take out what you don't need and make those changes.
Yeah, I mean, we're demoing a fairly short conversation, right? We imagine that a full-scale conversation would be much longer. We would have to ask more questions about how you want variables treated.
Yeah, excellent. Okay, so questions from Stefan. Stefan has 2 questions. Which NED does the wizard support? I guess which NED does the wizard support?
It's tested with XE and XR.
Okay.
But it seems likely it will work with almost anything. It's data-driven, right? There's no hard-coded support for it. I would expect that if you have an obscure device where the LLM doesn't know any of the configuration, it would be trickier. But for the main ones, I would expect it to work.
Yeah.
Okay. Does it support all device configurations? And I'll even add on to that. Can it support a underlying service configuration? So like a hierarchical type of service approach?
Not right now. Right now, it does support, it should be able to support all the device configurations supported by NSO nets. So that would be the limitation here. Mostly whatever the nets support, we would be able to support. But hierarchical service configuration is something we haven't gotten there. I think it would be part of the evolution of this package wizard.
Okay. What happens if the user doesn't give a good input?
Ideally, we should be actually
I saw that, right?
It would be stuck right now, but ideal cases, it would come back and ask the user for input again. It should come in and...
Which does, it just didn't do it in this demo, right?
Yes,
in a nicer setup, it does.
Right.
Because that's the point, right? So you talked about preconditions and dependencies. And that's a general idea here that the NED ID, for instance, it kind of depends on what you give it as input, right? How many steps it takes. So the idea is that if it doesn't have, if the dependency is cleared, if you sort of state the package name very clear in the prompt, you won't actually have to go into that prompt, because it will sort of accumulate knowledge as you go through the process and ask about stuff it needs to know.
Okay. So we're going to keep rattling these. We're a little bit ahead of schedule, so let's just answer all these. From Sasa, the next step would be a self-creating and self-healing NED. That's a question.
Yeah, I mean, we could do more. We could do more, maybe not, as I said, a lot of the self-healing stuff is operational context, which I think is more the foresight domain, and we're doing some stuff there. But for sure, for sort of the fixes, we could do more.
Okay. Are all LLM calls to generic LLMs such as ChatGPT? How are you injecting context?
So currently, all of the LLM calls are to generic ChatGPT, what we have. We have multiple adapters. We can also use Claude if required, but those are the 2 LLMs which we support right now. Regarding injecting context, we have this. So I was describing in one of the previous slides how we maintain global memory. The task framework itself maintains the memory, and that's where each task has access to all of the results or all of the data which are generated by other tasks. And with that, it would be able to pull in the context and add into the prompt and give the LLM the required context to generate the required output. Okay.
So just thinking about it, what we have DevNet, right? Cisco DevNet, where there's a lot of community services, a lot of community code. Does it tap into that database at all?
No, I mean, most of the LLMs, generic LLMs, are trained on all open source data. I believe DevNet is also open to public. So from my understanding, ChatGPT and Claude, they should have access.
You're right. Can you start package development with an existing device config data inside of NSO describing parts of the device model?
So not currently, right? Currently, you have to give it as explicit part of the input. It would be possible in the future if we wanted to, but today you would have to copy paste it from your show command.
That's right, yeah.
Okay. Can it use or modify an existing package to generate one with requested modifications? That was one of your poll questions. Can you use this to kind of modify an existing package?
Not right now. Right now, it only generates a brand new package, and you can use the Visual Studio plugins, what we have for NSO, to actually modify, but I believe it is part of our future roadmap, where we would want to actually support an existing package and enhance the existing package. That's definitely there in our vision.
Okay. This is exciting work. So I know you said it would be available beginning of next calendar year?
So the preliminary plan is first half of next calendar year. So we don't have a date.
Right. But if we have some customers that may want to get some feedback and try it in a beta phase, we're open to that.
We'd love to talk about it.
Okay, great.
Okay.